Now we discuss some questions on the chapter of surface chemistry. The questions will cover the different aspects of the topic surface chemistry, that includes physical adsorption, chemical adsorption and adsorption isotherms. Also includes colloids, that is lyophilic colloids, lyophobic colloids, characteristic properties of the lyophilic and lyophobic colloids, preparation of colloids, applications of colloids. All these topics will be covered and they will be highly useful for all different types of competitive examinations. Now first let us look at the question number 1. For the salt prepared by peptizing the freshly precipitated SnO2 with HCl. SnO2 is the freshly prepared precipitate. In this, the salt what you will get will give you a salt which is positively charged. It is a positively charged salt is what we will get it. For a positively charged salt is peptized by a negative anion, right. Higher the charge on anion, more is the coagulation. So here coagulation or what you call flocculation. So a positive salt peptized, and so here order of coagulation power, the order of coagulation power is sulphate and chloride. If you have, then sulphate is negative charge. So the order of coagulation power is among the given, it is the ferrocyanide greater than phosphate greater than sulphate greater than chloride. Therefore, means ferrocyanide is the one having highest coagulation power. So, flocculation value is that ferrocyanide less than phosphate less than sulphate less than chloride. Therefore, the least coagulation power is chloride, highest coagulation value is chloride. So, the answer for the given question is the chloride, that is KCl, that is option, that second option is the correct answer. Which of the following is not correct? In the second question some statements are given and which is not the correct statement is asked. The first option is that in the adsorption process surface energy increases. In the surface energy of this what you call the adsorbent decreases, that is the reason adsorption is a exothermic process. Next, adsorption is isoentropic process. Adsorption is not isoentropic process. For adsorption, the characteristics are that delta H is negative, delta S is positive and delta G is negative. So here the isoentropic process means the entropy change is 0, but entropy change is not 0 in the case of adsorption. Here the delta H is negative, delta S will be, in the case of adsorption, delta S is also negative, delta G is also negative, all three of them are negatives, because delta H is negative because surface energy decreases. Adsorption is isentropic, but it is not isentropic. Delta S is negative because the gas from more random state gets adsorbed into less random state. So, delta S is negative. Adsorption is exothermic. Of course, adsorption is exothermic, that is the reason we say that surface energy decreases. Adsorption is spontaneous, delta G is negative. So, here delta H negative, first option is correct, delta S is negative, second option is wrong, again delta H is negative, third option is correct, and delta G is negative, so fourth option is correct. So, the incorrect statement is second option, that is adsorption is isentropic is wrong. Now, let us move on to question number 3. Which one is not characteristic of fissorption? Here the options given are particularly about the fissorption, and again the question is which is not a correct statement. Sulfur dioxide gas is more adsorbed on 1 gram of charcoal compared to methane, because sulfur dioxide is having low critical temperature compared to methane. Here sulfur dioxide gas is more adsorbed on 1 gram of charcoal compared to methane, that is correct. But here the what the rule says is that easily liquefiable gases, or the other way of saying is gas with higher critical temperature will adsorb more. That means critical temperature for sulfur dioxide is greater than that of methane, therefore sulfur dioxide is more adsorbed. So, the first statement itself is a wrong statement. Second statement, fissorption occurs readily at low temperature. Here fissorption being exothermic process, delta H is negative. According to Le-Chatelier principle, a process for which delta H is negative will take place at low temperature. So, second option is correct. Enthalpy of fissorption is low due to weak van der Waals forces. Yes, delta H is negative, but it is low. Maximum it ranges only up to 20 kilojoule per mole. It is less. Whereas chemisorption it is more. The extent of fissorption increases with increase in surface area of adsorbent. Larger the surface area, more is the adsorption. So, here second, third or fourth options are correct. The incorrect is first option. So, the answer is option 1. Now, let us go to the question number 4. Find the wrong statement. Here again the similar kind of a question, because here if it's the topic surface chemistry is more theoretical. So, here we will have the mostly the questions of correct and incorrect statement type only, which are highly useful for competitive examinations and also useful in the multiple answer questions. So, let us look at the question. First option is Freundlich isotherm fails at high pressure. Freundlich isotherm is the one that is what we draw x by m versus p. When you draw a graph, then the graph what you will get is like this, and this is what we say x by m is proportional to p power 1 by n, and at high pressure what you will get is almost a constant value is we will get. So, here it won't distinguish at high pressure. Second option is silica gel is used to remove moisture and controlling humidity. Yes, silica gel is used to remove the moisture and controlling humidity, because silica gel adsorbs water. Oxidation of oxalic acid by potassium permanganate in acidic medium is an example of induced catalysis. This is not an induced catalysis, but oxidation of oxalic acid H2C2O4 by permanganate in acidic medium. The reaction is to CO2 plus H2O plus Mn2 plus. This Mn2 plus formed will catalyze the reaction. So, it is an example of autocatalysis, but not induced catalysis. So, that is the wrong answer. Chromatographic analysis is based on the phenomena of adsorption. Adsorption chromatography, the name itself it is what we call adsorption chromatography. So, it is based on the principle of adsorption. So, here the wrong statement or the correct answer is option 3. Question number 5. Zeta potential or electrokinetic potential is not dependent on. It is zeta potential or zeta potential or electrokinetic potential. It is the potential that is developed due to electrical double layer. For example, if you have a solution of a AgNO3 plus Ki, here what you will get is, you will get an AgI precipitate. To the AgI precipitate, excess of potassium iodide, when you add, what you will get is AgI, I minus sol and potassium ions. This is here what you will get, electric double layer. Now, so here what you will get, potential difference arises. This potential difference is what arises is what is called zeta potential. That zeta potential depends on the viscosity of the sol, yes, of course, and the dielectric constant, yes, the dielectric constant that is directly related to the potential difference. Velocity of the colloidal particles when the electric field is applied, that is what electrokinetic. Kinetic means depends on the velocity. The kinetic velocity of the colloidal particles when electric field is applied, the velocity with which the ions will migrate towards the respective electrode will matter or will affect the electrokinetic potential. And fourth one, Nernst potential. Nernst potential is the redox potential. Nernst potential is not electrokinetic potential. Nernst potential is a redox potential, potential that arises due to a simultaneous redox reactions in a galvanic cell. That is what we call Nernst equation. So, here first, second, third options will affect the zeta potential, but option 4 will not affect the zeta potential. So, that is the correct answer. Now, let us move on to the question number 6. The dispersal of freshly precipitated substance into a sol by the addition of an electrolyte in common is known as, in common it is called peptidization. So, in the previous examples also we have seen, or suppose if you have a sol of AgI, when we are having a precipitate of AgI, like in the previous question that we already discussed. Now, to this AgI, if you add an electrolyte, potassium iodide, right, then what will happen is you will get a sol AgI I minus. So, this is a precipitate. A precipitate is converted into this is sol by adding electrolyte. This is what is called peptidization. So, the correct answer for this is option 4. So, the correct answer is option 4. Let us move on to question number 7. Which of the following graph represents only monolayer physical adsorption? The monolayer physical adsorption, that is Freundlich adsorption isotherm, if you take X by m versus P when you draw a graph, then what you will get is like this, where we say X by m is proportional to P power 1 by n, or X by m is equal to K into P power 1 by n. At low pressure, this 1 by n value is equal to, low pressure 1 by n is equal to 1, high pressure 1 by n is equal to 0. So, when it lies between 1 to 0, at low pressure it increases as the pressure increases, it increases, and at high pressure it remains constant. So, the option 1 represents the, so here the correct answer is option 1. Option 1 is the correct answer. The other 3 graphs will not represent the monolayer physical adsorption. The second option is the chemisorption, third one is the double layer physical adsorption, so on and so forth. So, the correct answer is only the option 1. Now, let us move on to question number 8. Which of the following forms negative colloidal solution? First option AgI AgNO3. To AgI, if you add AgNO3, you will get Ag plus AgI sol. So, this is positive sol. Second option is SNO2 HCl. In SNO2 HCl, again what you will get is the H plus SnCl4 minus, that is again a positive sol. third one is HGS H2S. So, here what you will get is HGS S2 minus. So, this is here you will get a negative sol, and fourth option is AlOH thrice HCl, AlOH thrice HCl when you add. So, here you will get it as H plus AlOH thrice positive sol is what you will get. So, here finally what you will get is the third option, it is the option 3 is the correct answer, as you are having negative sol over here. So, correct answer is option 3 HGS H2S. Let us move on to question number 9. A sol has positively charged colloidal particle. Which one of the following solution is required in lowest concentration for coagulation? So, here as the sol is positive, so the coagulation must be made with negatively charged particle. So, here if you look at it, NaCl, K4FeCN6, ZnCl2, Na2SO4. So, here Cl minus is having a negative charge, but it is least negative charge. Ferrocyanide ion is the one having highest negative charge. So, this is the one that will have the highest coagulation power or least coagulation value. ZnCl2 again Cl minus, and Na2SO4, that is SO4 2 minus. These two are minus 1 charge, this is minus 4 charge, this is minus 2 charge. The higher the charge on opposite ion, more is the or highest is the coagulation power. So, here higher charge is for ferrocyanide ion. So, the correct answer is option 2. So, ferrocyanide is the correct answer. Now, let us move on to question number 10. Which of the following is wrong statement? This question is again the correct incorrect statement. In physisorption, both monolayer and multilayer formation can take place. Yes, in physisorption it is both monolayer and multilayer, because the physisorption is basically due to the unbalanced valence forces. So, when one layer of adsorption takes place, still if the residual forces are not balanced, then it will get stack of the molecules that gets adsorbed. So, that stack leads to multilayer. That multilayered formation will be keep taking place till the forces are totally balanced. So, multilayer adsorption will take place in the case of physisorption, but it is not possible in chemisorption. So, first option is correct. Charge and the lyophilic colloid of amino acids will depend upon pH of solutions, considering the change in pH value. Yes, charge and lyophilic colloid of amino acids will depend upon the pH of solution. Yes, exactly, because in the case of amino acids, what we will have is a positive charge, and here you will have the RC, and on the other hand you will have a COO minus. Now, at isoelectric point you will have the positive and negative charges equal. So, overall whether it carries a positive charge or the sol is positively charged or negatively charged, it all depends on the what you call the pH of the solution. The pH is such that it releases H plus ion or it releases OH minus ion. Based on that, we should be able to say. So, it is correct statement. The next, inhibitors decrease the activity of catalyst by getting adsorbed on the catalytic surface. Inhibitors decrease the activity of a catalyst by getting adsorbed on the catalyst surface. Yes, inhibitor means which reduces the rate of a reaction. The inhibitor, what it do is, actually in heterogeneous catalysis, gas gets adsorbed on the surface of the metal, and in the place of the gas that is to adsorb, if any other impurity or foreign particle, that is inhibitor, if it is gets adsorbed, then the extent of adsorption of gas on the surface decreases. So, third option is also correct. And flocculation value is directly proportional to charge of the ion. Flocculation value is inversely proportional to charge of the ion. As in the previous examples we have seen, FeCN6 4 minus is the one with least flocculation value. Chloride ion is the one with highest flocculation value, because here the charge is highest. If the charge is highest, flocculation value is least. If the charge is least, flocculation value is highest. So, here the correct answer is option 4. Now, the question reads that gold number of a lyophilic sol is such a property that, first of all, what is gold number? Gold number is the weight of a lyophilic sol in milligram required to prevent coagulation of 10 ml gold sol upon adding 1 ml 10% NaCl solution. So, it is the purpose of adding a lyophilic sol is to prevent coagulation in lyophobic sol, which causes by adding an electrolyte. So, the ability of lyophilic sol, the purpose of adding lyophilic sol to protect the colloid. So, it will give protection from peptization, and more you add, lesser is the peptizing power. If the lyophilic sol is having a high protective power, then it is required to add very less. So, higher the gold number, lesser is the protection, or on the other way around, lesser the gold number, more is the protection. So, in the given options, if you look at it, in the option 3, the lower is its value, the greater is the protecting power. Therefore, option 3 is the correct answer. The remaining are the wrong answers. This again the correct incorrect statement type. What it reads is the first statement: hydrophilic colloid is a colloid in which there is a strong attraction. This is what the basic difference of lyophilic sol and lyophobic sol. Lyophilic sol means there is a strong attraction between particle and the dispersed phase and dispersed medium. Lyophobic sol means the attractions are least between dispersed phase and dispersed medium. So, hydrophilic means that is strong attractions exist. Then hydrophobic colloid is a colloid in which there is a lack of attraction. Yes, that is what the basic definition of lyophilic and lyophobic. And hydrophobic sols are often prepared by selective adsorption of ion over a molecule. And hydrophobic sol, as in the previous examples that we have seen, that gold sol is prepared by method called Buddick-Sark method, and silver iodide salt is prepared by silver iodide precipitate and selective adsorption of iodide ion, or silver ion on a silver iodide. Like this, we have a selective precipitation of one ion over the precipitate of the particular substance. So, for 1, 2, 3, all 3 options are correct. So, the correct answer is option 4, all the above. All the given options are correct. So, the correct answer is option 4. Now, let us look at the question number 13. For surfactants, the incorrect statement about the critical micelle concentration, CMC, critical micelle concentration. What is critical micelle concentration? Critical micelle concentration is the minimum concentration required for formation of a micelle. The minimum concentration required to form micelle is what is called critical micelle concentration. Below critical micelle concentration, the dispersed phase will behave as an electrolyte, above which it forms a colloid. So, above the, and here also we have to know about the Kraft temperature. Kraft temperature is the temperature the minimum temperature above which CMC is attained. If the temperature is below craft temperature, whatever may be the solute concentration, but still micelle is not formed. So, the first option here, it reads above the craft temperature, with increase in temperature CMC decreases, reaches minimum and then it increases. Yes, it is true. And when hydrophilic part and the number of carbons in hydrophobic part is same, cis isomer has a higher CMC than trans isomer. Yes, this is also correct, because in the case of cis isomer, if you have a cis isomer, then cis isomer is more polar, trans isomer is non-polar, and for a micelle to form, what is required is charge is required. So, here it will provide the sufficient charge. So, is the reason that cis isomer is definitely will have the greater CMC than the what you call the trans isomer, which is non-polar. Next, when equivalent hydrophobic groups are present, CMC order is that ionic surfactants. When equivalent hydrophobic group is present, then the CMC order is that ionic surfactants greater than zwitterion and zwitterion is greater than non-ionic. That is true. So, if you are having here, you are having suppose a negative charge, then zwitterion where you have both positive and negative charge on the other end, and of course, then you have non-ionic where no charges are present. Charges are the main reason for micelle to form. Because of the repulsions, then they will not attract too much, there will be a repulsion, and because of the repulsions, the micelle is formed. So, here you will have the similar charges. So, the ionic will have what you call highest CMC, and when equivalent hydrophobic groups are present, with increase in number of hydrophilic groups, CMC will increase, because increase in hydrophilic groups increases the total concentration. So, here the incorrect statement is option 4, where it says 1.3 liters of nitrogen gas at 2 atmosphere pressure and 300 Kelvin in a container is exposed to 4 grams of solid surface. After complete adsorption, the pressure of nitrogen is reduced by 30%. Then what is the value of x by m? So, here it is given that initial pressure is 2 atmosphere, volume is constant, it is the volume of the gas is 1.3 liters, and the temperature is 300 Kelvin, and this pressure is reduced to 30% reduced. So, the pressure has become what you call if this is the initial pressure, then this is P1 and this is P2. This P2 will become equal to 1.4 atmosphere. So, now from the ideal gas equation, you have the relation P V equal to nRT, from which where V R T are constants, then you can write that P1 by P2 is equal to N1 by N2, which is equal to W1 by W2. P1 by P2 is equal to W1 by W2. So, when this is got reduced by 30%, so finally, then the weight of nitrogen adsorbed, you will get it as 0.88 grams. 0.88 grams is the weight of nitrogen that is adsorbed on the 4 grams of charcoal. 0.88 grams is adsorbed on 4 grams of charcoal. Therefore, x by m, that is the weight of the gas adsorbed, that is 0.88, by the weight of adsorbent, that is 4. So, it is equal to 0.22 grams. So, this is the value of x by m. So, the correct answer is option 1. Option 1 is the correct answer. Let us move on to question number 15. The critical temperature of SO2, CO2 and NH3 are 157, 31 and 133 degrees Celsius respectively. The volume of the gas is adsorbed by given mass of adsorbent and similar conditions. So, here even in one of the previous questions also we told that higher the Tc, higher is adsorption, higher is adsorption. Therefore, here the Tc order is that 157 for sulfur dioxide, 31 for carbon dioxide and 133 for ammonia. So, the order is that sulfur dioxide greater than ammonia greater than carbon dioxide. Therefore, the extent of volume of gas adsorbed also follow the order that SO2 greater than ammonia greater than CO2. So, the correct answer is option 1. So, it is option 1 is the correct answer. Now, let us move on to question number 16. A plot of log x by m versus log p for the adsorption of a gas and a solid gives a straight line with slope equal to. So, here it is on the Freundlich adsorption isotherm, if you write x by m is proportional to p power 1 by n, and from this what you can write is x by m is equal to k p power 1 by n. So, now if you take log x by m is equal to log k plus 1 by n log p. So, if you draw a graph for log x by m versus log p, then you will get a straight line, you will get a straight line like this, where the intercept is equal to log k and the slope is equal to 1 by n. So, the slope is equal to 1 by n. So, the correct answer here is option 1 is the correct answer. Now, let us go to question number 17. Which among the following is incorrect? Oxygen is adsorbed on a metal by virtue of its oxide formation. Yes, it is correct statement. The oxygen gets adsorbed on the metal surface because of the oxide formation. Hydrogen gets adsorbed on the metal surface by hydride formation. Nitrogen gets adsorbed by nitride formation. So, first option is correct. Hydrogen is adsorbed by transition metal due to hydride formation. Yes, that is correct. Physisorption of a gas adsorbed at low temperature may change into chemisorption at high temperatures. Exactly. Above 1000 degrees Celsius, nitrogen below 1000, nitrogen adsorbs on iron, that is physical adsorption, and when the temperature is above 1000 degrees, then that physisorption converts to chemisorption due to the formation of nitride. So, at low temperatures, gas adsorbed on the metal surface is physisorption, and at high temperature the metal absorbs, the gas adsorbed on the metal is chemisorption. So, it is a correct answer is 1, 2, 3 are the correct answers. Now, let us look at the fourth option. Usually less pressure is favorable for chemisorption. No, for chemisorption to take place, because it is a chemical reaction that has to be taken place. So, it is a high pressure that is required. So, the wrong statement in this is option 4 is the incorrect statement, and that is the correct answer. Now, let us move on to question number 18, which says that in an adsorption study of acetic acid CH3COOH from aqueous solution by charcoal, 200 ml of 0.2 normal acetic acid, 200 ml 0.2 normal acetic acid means milliequivalence of acetic acid is equal to 40, which is equal to, then weight of acetic acid is equal to 40 into 60, molecular weight of acetic acid is 60, that is equal to 2.4 grams. So, 2.4 grams of acetic acid is given acetic acid, and in that now after adsorption on 10 grams of charcoal, on 10 grams of charcoal, on 10 grams of charcoal after adsorption, then the left is require 50 ml of acid, require 25 ml of 0.2 normal NaOH. So, milliequivalence of NaOH is equal to 5, which is equal to milliequivalence of acid, and therefore, in 200 ml milliequivalence of acid left will be equal to 20 milliequivalents, that is, therefore, weight of acid left in 200 ml, weight of acid left in given 200 ml will be 20 into 60, that is 1.2 grams. 1.2 grams is left, 2.4 grams is given. Therefore, weight of acetic acid adsorbed is 1.2 grams on 10 grams of charcoal. Therefore, per gram it is 1.2 by 10, that is 0.12 gram. So, the correct answer is option 2. Option 2 is the correct answer, that is 0.12 gram. Now, let us look into the question number 19. Here the properties of colloidal particles are given, colloidal salts is given in column 1, and the reason for that property is mentioned in the column 2. Now, for the given property, what are the correct reasons? We have to find it from the column 2. Let us look at the first property, that is Tyndall effect. Tyndall effect is because of the scattering of light through colloidal particles. So, it is a scattering of light and the colloidal sized particle that should be in the range of 100 angstroms. So, it should be Q and T. And for coagulation, coagulation is all because of the charge present on the particle. So, coagulation, the option is R, that is neutralization of charge. And coming to the electrophoresis, electrophoresis is because of the what you call the charge as well as the unequal bombardment of the it is because of the charge, provided the size must be the colloidal range. And of course, in the electrophoresis what also takes place is the neutralization of charge as the salt particles move towards a particular electrode. So, it is RST, that is what you call neutralization of charge, presence of charge, particle size in the range of 100 angstroms. And Brownian movement, the Brownian movement is again the basically unequal bombardment of the solvent molecules. The size should be in the range of colloidal size, that is 100 angstroms, and also it is because of the presence of the charge. So, the Brownian movement is because of the PST. So, now if you look at all the options that are given, A QT, B R, C RST, D PST, that is question number 19 is the option 2 is the what you call correct answer. Option 2 is the correct answer for question number 19. Question number 20. Brady's arc method cannot be used to prepare colloidal solution of which of the following? Brady's arc method, it is Brady's arc method. This is a special method of preparation of metal salts, any metal salts, and it is an electrolytic process. In electrolytic process, by it is electrolytic dispersion. It is a metal whose salt is to be prepared is taken as the electrode, and when a high current, when a high voltage current is applied, the metal vapors will get dispersed into the what you call the electrolyte, usually taken as a sodium hydroxide. And here the most preferably this Brady's arc method is mostly used for the metals like platinum, silver and gold. Iron is not prepared by this Brady's arc method. Well, least volatile metals like platinum, silver, gold are only prepared in this method. So, not prepared is the iron, that is option 3 is the correct answer for this question number 20. Now, let us go to question number 21. Which of the following colloid is used as a medicine for stomach disorders? Argirols, colloidal antimony, milk of magnesia, colloidal gold. It is a milk of magnesia, that is magnesium hydroxide. Magnesium hydroxide being a alkali neutralizes stomach acids. Therefore, it is a magnesium hydroxide, that is a option what you call 3, milk of magnesia is the correct answer for this question number 21. Question number 22. Lyophilic salts are reversible. Lyophilic salts are reversible, they are not irreversible, because if once the sol is formed, if the sol is separated back into the dispersed phase and dispersed medium, those dispersed phase and dispersed medium again and combining you can get the salt back. So, they are reversible, they are not irreversible. So, first option is wrong. Second option, it is the lyophilic salts are prepared from organic compounds like starch, cellulose, etc. So, they are organic compounds, but not inorganic compounds. So, option 2 is also wrong. Third option, they are coagulated by adding electrolytes. They are not coagulated. They are not coagulated. They are highly stable. They are highly stable. Why they are highly stable? Because of the greater attraction between what you call dispersed phase and dispersed medium. So, they are highly stable, you can say, or they are self stabilized. Self stabilized. No need to add anything or no need to remove anything. They themselves are stabilized. So, the correct answer here is the correct option for the property of lyophilic salts is the option 4. Now, let us move on to question number 23. Which among the following ion has the highest coagulation power for AH2S3? AH2S3 is the preferred adsorbate is sulfide. So, it is a negative sol. So, any positive ion will allow the coagulation, and higher the charge, higher is the coagulation. Higher the charge, higher is the coagulation. So, here which the ion with highest positive charge, that is Al3 plus. The order is here as Al3 plus is having the highest charge. So, that will have highest coagulation power. So, here the correct answer is option 3 is the correct answer. Question number 24. Ferric hydroxide is a positive sol. Ferric hydroxide is Fe3 plus FeOH thrice. So, it is a positive sol. Here you are having a positive charge. Now, this for the positive charge sol, the highest capacity to precipitate, that is again coagulation. Coagulation is by negative charge, and here again highest negative charge, if you consider, highest negative charge is present on the ferrocyanide in the given 4 options. So, ferrocyanide is the correct answer. So, the correct answer is potassium ferrocyanide. So, the option is option 2 is the correct answer. Now, let us move on to question number 25. During chemical adsorption, the property which can be observed is, chemical adsorption is all because of the the chemical adsorption is because of the residual valence forces. It is a covalent bond formation takes place, and the adsorption is due to chemical bond formation. So, it is not reversible, it is irreversible, and the adsorbent molecule are held strongly on surface. So, that delta S and delta H are both negative. Yes, first of all, whether it is physisorption or chemisorption, as already in the beginning we told, it is delta H is negative, delta S is negative, delta G is also negative. So, second option is the correct option. First option, reversible, is not, they are irreversible. Third option, adsorbent molecules are held strongly on the surface. So, that delta S and delta H both are positive. No, both are negative, and during chemical adsorption delta S is negative and delta H is positive is also wrong, as already we mentioned, all 3 of them are negative. So, the correct answer is option 2. Now, in the question number 26, here some statements are given during chemical adsorption of a gas on solid surface. Which one of the following can be observed? Decrease of pressure favors adsorption. Decrease of pressure does not, because x by m is proportional to p power 1 by n. This is Freundlich adsorption isotherm, or x by m is equal to AP by 1 plus BP. So, it is all high pressure only favors the chemisorption, and delta H is negative. So, low temperature favors chemisorption. As the temperature increases, in the case of chemisorption, that increase in temperature increases adsorption and then decreases, because even though for this also delta H is negative, low temperature is favored, but it requires some activation energy. the activation energy is required for the adsorption to take place. So, in order to acquire the required activation energy, temperature has to rise. After that, then it decreases because delta H is negative. Then activation energy is not an essential condition for chemisorption. No, activation energy is an essential condition for chemisorption. So, overall here the correct answer is option 3 is the correct answer. Now, question number 27, select the correct statement. Water in oil emulsions, this is regarding emulsions. Water in oil emulsions are less viscous than the aqueous emulsions. No, because oil in water is less viscous and water in oil is more viscous, because here oil content is more, water content is less. So, water in oil is more viscous. So, first option is not a correct statement. An emulsion can be diluted with water, then it is oil in water type emulsion, and then it is oil in water type emulsion. If in a oil in water, if you dilute it with water, it converts to water in oil. So, option 2 is correct. Option 3 is that electrical conductance of aqueous emulsion is less than that of what you call oil emulsion. No, conductance of water in oil emulsion is less than oil in water, because here in oil water content is more ionization takes place. Here you will have more charge separation. Then de-emulsification can be done by soap or detergent. Soap or detergent, soap is not de-emulsification, soap is emulsifying agent. Soap is emulsifying agent, means it leads to emulsification, not de-emulsification, or rather soap stabilizes. Soap stabilizes emulsion. So, here finally the correct answer is option 2 is the correct answer. Now, let us move on to question number 28. What it reads in question number 28 is, milk is an example of oil in water type emulsion, and of course, that is a correct statement. Cold cream is an example of water in oil type emulsion, that is also correct. Milk is an example of oil in water. Yes, it is a lactose, that is lactose, an oily substance that is present in water, lot of water. So, that is water in oil, and oil in water. Cold cream is a gel like, so it is water in oil, it is more viscous. So, cold cream is more viscous than milk. So, from that at least we can understand easily that milk is oil in water type emulsion, cold cream is water in oil emulsion. So, the correct answer is option 3 is the correct answer. Now, let us move to question number 29. Which of the following statements are wrong for physisorption? Physisorption is reversible. Yes, because physisorption is a van der Waals adsorption. It is a van der Waals adsorption. So, it is weak. This being a weak, what you can say is it is reversible, whereas chemisorption is irreversible. It requires energy of activation. No, it does not require energy of activation. Chemisorption requires energy of activation. The value of adsorption of enthalpy is low. Yes, it is true. It is 20 kilojoule per mole, whereas for chemisorption it goes up to 200 kilojoule per mole, and it generally occurs at low temperature. Yes, because delta H is negative, it occurs at low temperature. So, the wrong statement is option 2. So, the answer is option 2. Now, let us move on to question number 30. Which of the following is a macromolecular colloid? Macro means single large sized polymeric. Yes, it is starch is C6H12O6. it is large sized. So, it is macromolecular colloid, whereas soap is a micelle, it is a aggregation. It is an aggregate. Soap is an aggregate. Detergent is also an aggregate. Detergent is also an aggregate, and gold is a metal sol. Gold is a metal sol. It is not, or rather it is gold is a metal sol. Soap and detergent are aggregates which are micelles. So, single large size polymeric molecule is only the starch. So, the correct answer is option 1. Now, in the question number 31, what it is given as 1 mole of Ag plus AgI. For the 1 mole of Ag plus AgI, this being a positive sol, for coagulation what we require is 1 mole of, or 1 equivalent of negative charge, that is 1 mole I minus is required, or it is, so it is 1 mole of potassium iodide, 1 liter of 1 molar potassium iodide, this is also equal to 1 mole of Ki. So, this is also ok, and 500 ml of 2 molar K2SO4. So, this is 500 ml of 1 molar K2SO4. So, here this is equal to 2 normal K2SO4 this is. So, here this is again equal to 1 equivalent, or that is equal to 1 mole. So, all 3 of them are useful. So, option 4, that is all of this is the correct answer. Now, 32nd question, correct statements among the following: spontaneous adsorption of gases on solid surface is an endothermic process. No, delta H is negative, it is exothermic, but not endothermic. Reactant molecules are adsorbed on the surface by van der Waals forces and chemisorption. No, chemisorption is because of not van der Waals forces, but it is because of valence forces. Because of valence forces, and a colloid of ferric hydroxide is prepared by adding little excess of NaOH and FeCl3. Yes, FeCl3, NaOH, when you have in excess, then what you will have is ferric hydroxide on which hydroxide adsorbs. So, you will get a negative sol. So, third option is correct, and fourth option, chemical adsorption does not involve activation energy. Chemical adsorption requires activation energy. So, the correct option is option 3. So, the answer is 3. Let us see the question number 33. The correct conditions to observe Tyndall effect. First of all, Tyndall effect is scattering of light through colloidal size particles in a sol. It is the blue color of the sky is because of the Tyndall effect, because the dust in the air is a colloid, and scattering of light through those dust particles is what makes it appear in blue color. So, then what should be the refractive index and colloidal sized? Regarding that, if you look at these options, the diameter of the dispersed particle are greater than the wavelength of the light. No, it should be less. Then refractive index of the dispersed phase and the dispersed medium differ greatly in magnitude. Yes, they have to differ, otherwise the what you call the Tyndall effect, scattering of light, will not take place. And refractive index of the dispersed phase and the dispersed medium differ in smaller magnitude. No, they should be differ greatly, as in the second option it is given. The diameter of the dispersed particle are not much bigger than the wavelength of the light. No, they should be bigger, then only it will take place. So, the correct answer is option 2. That is, the refractive index of the dispersed phase and dispersed medium must differ greatly. Question number 34. Which is not the aerosol type of colloid among the following? Aerosol means in aerosol dispersed medium is air. So, smoke is definitely an aerosol because it is present in the air. Milk is not, because milk is an aquasol. Dispersed medium is water. Cloud is present in air, so it is aerosol. Fog is also present in air, that is also aerosol. So, milk is aquasol, it is not aerosol. Therefore, the answer is option 2. Question number 35. Which one of the following statements is correct? Porous solid possess lesser surface area. No, porous solids cannot possess lesser surface area, because if the pores are more, then the number of active sites will become less and the surface area decreases. X by m increase with increase in surface area of solid. Yes, it is true. Greater the surface area, more is the extent of adsorption. Easily liquefiable gases are adsorbed less. No, easily liquefiable gases or the gases with high critical temperature will adsorb more. Next, physical adsorption is monolayered at high pressure. Physical adsorption is not necessary to be monolayered at high pressure. In fact, there can be multi-layered. So, here the correct answer is option 2, that is X by m increases with increase in surface area of the solid. So, the correct answer is option 2. In the question number 36, it says which of the following statements is not correct? Chemical adsorption increase with increase in temperature. Chemical adsorption increase with increase in temperature initially reaches maximum and then of course, it decreases. So, partly it is correct. Physical adsorption is irreversible. No, physical adsorption is reversible. Physical adsorption is reversible. Chemisorption increases with increase in pressure of gaseous adsorbent is correct, and physorption is not specific. Physorption is not specific, means any gas can be adsorbed on any adsorbent. Any gas can be adsorbed on any adsorbent. It is not specific. So, the correct answer is option 2, that physical adsorption is irreversible is the wrong option. Now, let us move on to question number 37. The correct order of volumes of the gases methane, sulfur dioxide and hydrogen adsorbed by 1 gram of charcoal is, as the Tc for SO2 greater than methane greater than H2, therefore, X by m is also higher for sulfur dioxide than methane than hydrogen. Therefore, the correct answer is option 2, SO2 greater than methane greater than hydrogen. Correct answer is option 2. Question number 38. Which of the following is true about the effect of temperature and adsorption? Physorption increase with rise in temperature. Physorption decrease with rise in temperature, because delta H is negative. So, low temperature require physorption. Chemisorption decrease with rise in temperature. Chemisorption decrease, either it is chemisorption or physorption, delta H is negative. So, we think chemisorption also chemisorption decrease with increase in temperature is correct, but initially it will increase. and option 3 is at 463 Kelvin nitrogen gas undergoes chemisorption. No, not at 463. At 723 Kelvin nitrogen undergoes chemisorption, because at 723 nitrogen reacts with iron to form nitride, and below 723 it is fissorption. So, the correct answer is option 4, that at 723 Kelvin nitrogen gas undergoes chemisorption. Next, now let us look at the question number 39. Coagulation, this is regarding the coagulation power of ions again, that for correct order of coagulation power of ions of different charges is that phosphate greater than sulphate greater than chloride. So, it is a phosphate greater than sulphate greater than chloride, that is option 4 is the correct answer. Now, let us move on to question number 40. In the question number 40, what it says is, the minimum mass of potato starch required to be added to 10 ml of gold salt to just prevent its coagulation by adding 1 ml of 10% NaCl solution is 25 milligrams. So, the goal number of the potato starch is, it is 25, because what is the definition of gold number says? First of all, the gold number is the amount of lyophilic salt, the amount of lyophilic salt, in this case it is potato starch in milligrams, that here it is given 25 milligrams. So, this is 25 milligrams required to add to 10 ml of gold salt. In the given question it is 10 ml of gold salt to prevent coagulation from 1 ml of 10% NaCl, and in the given question also it is given 1 ml of 10%. So, the weight of potato starch that is required to add is 25 milligrams. Therefore, gold number of potato starch is 25. So, the correct answer is option 2. The correct answer is option 2.